Welcome back to module number 2, differential equations. So in this module we'll first discussing the order and degree of the differential equation. So you know that order of the differential equation is the order of the highest derivative present in it here. For example, 1 plus dy by dx whole square raised to cube is equal to c square into d square y by dx square whole square here. So if you observe the dy by dx in left hand side and right hand side, so left hand side dy by dx, right hand side is d square y by dx square. So here left hand side is first order and right hand side it is second order. So its power is 2 means highest order is 2. So we say that order of the differential equation is 2. Suppose if left hand side in place of dy by dx, if it is d raised to 4 of y by dx raised to 4, then we say that order of the differential equation is 4 here. So that is the highest derivative present in any given differential equation is called order of the differential equation. Then degree of the differential equation. So degree of a differential equation is degree of the highest ordered derivative present in it after the equation has been free from the fraction here. So already explained example 1 in order. So highest order is d square y by dx square. So its power is 2. So it denotes that its degree is also 2 here. So in any given differential equation, so first one you will check it the order here. So highest order is called its order of the equation and its power denotes the degree of the differential equation. So here y equal to dy by dx is equal to x into dy by dx whole square. So in both the side the order of the differential equation is 1 here. But in right hand side the power of dy by dx is 2. So it denotes that degree is 2, order is 1 here. So first order second degree differential equation. So this is about order and degree of the differential equation. The next one is linear differential equation of second and higher order with constant coefficient. A differential equation of the form or of order n is in the form of d raised to n of y by dx raised to n plus a1 d raised to n minus 1 of y by dx raised to n minus 1 plus a2 d raised to n minus 2 into y by dx raised to n minus 2 and so on up to a n y is equal to pi of x here. So equation number 1. So in this equation here a1, a2, a3, an, so these are called constant and this equation is called linear differential equation with nth order with constant coefficient, and here phi of x, so it is the function of x here. So now we expressing equation number 1 in symbolic form here. So in place of d by dx we will denoting capital D. So d raised to n by dx raised to n become capital D raised to n. Similarly d raised to n minus 1 of y by dx raised to n minus 1 become d raised to n minus 1 and so on up to an y is equal to pi of x here. So this left hand side is also denoted as f of d into y. So f of d denotes d raised to n plus a1 d raised to n minus 1, a2 d raised to n minus 2 up to an. So which is equal to pi of x here. Say this one as equation number 2. So suppose if right hand side, that is phi of x is equal to 0, then f of d into y is equal to 0. So if f of d into y equal to 0, then the equation is said to be homogeneous equation. Suppose if phi of x is not equal to 0 or f of d into y is not equal to 0, then the function or equation is said to be non-homogeneous equation. So you will remember it, if the equation is equal to 0, homogeneous equation. If equation is not equal to 0, that is called non-homogeneous equation. The next one is solution of homogeneous second order linear differential equation. So consider the homogeneous equation d square y by dx square plus p into dy by dx plus q into y is equal to 0. So equation number 1. So here p and q are the constant, and the symbolic form of equation 1 is d square plus p into d plus q into y is equal to 0. So and here d denotes d by dx. Suppose if you substitute d is equal to m, so you will get it m square plus pm plus q equal to 0. So equation 3 is called auxiliary equation, or it is also called characteristics equation of the differential equation. And equation 3 is quadratic in m or quadratic equation, and we know that quadratic equation has 2 roots here. So if it is m square, 2 roots, so starting point m cube, then 3 roots. If it is m raised to 4, equation having 4 roots here. So here in quadratic equation there are 2 roots, and these 2 roots are either real and distinct. Distinct means different roots, real and different roots. Second possibility is real and coincident or equal roots, real and equal roots. And third possibility is roots are complex here. So these roots are either real and different roots, or real and equal, or roots are complex here. So we will discussing these 3 roots one by one, and how to write the characteristics equation or general equation of these 3 different roots one by one here. So case number 1, when the roots are real and different roots, say m1 and m2. If m1 and m2 are the 2 different roots, or m1 is not equal to m2, then the general solution of equation number 1. So its general solution is y equal to c1 e to the power m1x plus c2 e to the power m2x here. And here c1 and c2 are constant. Then second one is case 2, if the roots are equal, say m1 and m2 are same, that is denoted as m. Hence the general solution of equation number 1 is y equal to c1 plus c2x into e to the power mx. So which is the general solution of equal roots here. And case number 3, when the roots are complex, say the complex roots are in the form of alpha plus or minus I beta form. So here alpha is called real part and beta is called imaginary part here. So its general solution is e to the power alpha x into bracket c1 cos beta x plus c2 sin beta x here. So this is the general solution when the roots are complex here. So you will remember it, when the roots are different, its general solution is in this form. If the roots are equal and roots are complex, so you will always write general equation in this form here. So these 3 cases will help us while writing the complementary functions. So here notes, the complementary function, or it is denoted as CF, which itself is the general solution of differential equation, and complementary function is denoted as yc equal to c1 y1 plus c2 y2, and here c1 and c2 are constant. Then particular solution. So particular solution of non-homogeneous equation or non-homogeneous function is denoted as yp and is called particular integration, or we can also denote particular solution as it is the form of solution of a differential equation with specified values assigned to the arbitrary constant here. So it is form of the solution, or a solution of differential equation. We can also define particular integral as it is the form of solution and which is not containing any arbitrary constant here. So complementary function containing arbitrary constant, but particular solution which cannot contain any arbitrary constant here. And complete solution, so complete solution means you will add the result of complementary function and particular integral, so which gives the complete solution, and it is denoted as y equal to yc plus yp, or it is also denoted as y equal to cf plus pi, complementary function plus particular integral. So now here we will give the table to how to write the complementary function here based on the roots of the auxiliary equation. So first column is roots of auxiliary equation, second column denotes its complementary function. So first one, roots are 7 and 8. So both the roots are different. So therefore its complementary function is according to case number 1. Earlier we will discuss c1 e to the power 7x plus c2 e to the power 8x. Then second one, 2 minus 2, 3 and minus 3. So these are also different roots because their sign is different here. So hence its complementary function is c1 e to the power 2x plus c2 e to the power minus 2x, c3 e to the power 3x and c4 e to the power minus 3x. Third one, roots are 0, minus 5, minus 5 and minus 5. So 0 and minus 5, minus 5. Again these two are different roots. So 0 is different root, minus these 3 minus 5's are same roots here. So when the roots are in this form, its complementary function is c1 e to the power 0x. And we know that e to the power 0 is 1. Either we will write only c1 or c1 e to the power 0x. Then remaining 3 roots are same. Then its complementary function is c2 plus c3x plus c4x square e to the power minus 5x. Then roots are 3 plus or minus 4i. So 3 plus or minus I means roots are complex, alpha plus or minus I beta form. Its complementary function is e to the power 3x, c1 cos 4x plus c2 sin 4x. And fifth one, roots are plus or minus 5i. So here real part is absent, only imaginary part here. So its complementary function is c1 cos 5x plus c2 sin 5x. So examples on this homogeneous function and its complementary function. So first one, solve d square y by dx square minus dy by dx minus 6y is equal to 0. So first one we will expressing the differential equation in symbolic form d square d and 6 here. Now replacing again d by m, so which gives the auxiliary equation as m square minus m minus 6 equal to 0. So now factorize this quadratic equation and we'll get it the roots as 3 and minus 2, or otherwise by using the calculator you will get it the roots of quadratic function as 3 and minus 2, and here 3 and minus 2 are two different roots. So hence its general solution is c1 e to the power 3x and c2 e to the power minus 2x. Second example, so already here given equation is in symbolic form d square plus 8d plus 16 is equal to 0. So auxiliary equation is m square plus 8m plus 16 equal to 0. So its roots are minus 4 and minus 4. So both the roots are same or equal roots. So hence its general solution is c1 plus c2x e to the power minus 4x. Third example, d cube y by dx cube 6 d square y by dx square plus 11 dy by dx plus 6y equal to 0. Solution. So first one we will writing the symbolic form of given differential equation. Next one is auxiliary equation, t is replaced by m. So while solving manually, so first one will substitute suitable value of m here such that the equation become 0. So here we will substituting m equal to -1, then the equation become 0, and m equal to -1 denotes the first root of the cubic equation. So with the help of m equal to -1, now we will calculating remaining two roots by applying the synthetic division method here. So synthetic division method is, you will take the coefficient of m cube, m square, m and constant here 1, 6, 11 and 6, and also use the first root m equal to -1. So here we always writing 0 first, then add 1 and 0 which gives the 1. Now multiply -1 and +1 and write here, and again add 6 minus 1 which gives the 5, and once again multiply 5 into -1, write here -5, and 11 minus 5 gives 6, and lastly 6 into -1 -6. So +6 -6, last value is always 0. Now we will expressing these numbers in the equation form as m square plus 5m, and last one is constant here. So here we will reduce the cubic equation into square equation or quadratic form. Then we will easily get it the remaining two roots of quadratic equation. So after factorizing we will get it -2 and -3. So equation is cubic means it has three roots. One is m equal to -1. Another two roots are -2 and -3. So all the three roots are different. Hence its general solution is c1 e to the power -x plus c2 e to the power -2x plus c3 e to the power -3x. Or otherwise by using the calculator you will calculate the roots of cubic equation, then also you will get it -1, -2 and -3. So here also equation is cubic, we will substituting suitable value of m, that is m equal to -1, equation become 0. So now use the synthetic division method to calculate remaining roots here. So use the coefficient of d cube is 1. Here d square and d is absent, therefore you choosing the coefficient of d square and d as 0 and 0, and last term is constant, that is coefficient of y is 1. Now use 0 first, and with the help of m equal to -1. So 1 plus 0 1, -1 into 1 -1, 0 minus 1 -1, -1 into -1 plus 1, 0 plus 1 1, 1 into -1 -1 plus 1 -1 again 0. So again express these 1 -1 in equation form, m square minus m plus 1 equal to 0. So again you will get it the quadratic equation, and its roots are 1 by 2 plus or minus square root of 3 by 2 higher. So roots are again different, one is real number, another one is complex roots here. So its general solution is c1 e to the power -x plus e to the power x by 2, c2 cos square root of 3 by 2x plus c3 sin square root of 3 divided by 2x.